problem says please refer to the picture and find the gravitational forces acting on mass M, C, and locate on the axis due to masses M A and M B. And we know Y initial and X initial is 30 M. And to find the magnitude of the force acting on the X component and the Y component in the direction of all masses. Okay, so we have a couple equations that we could start with. So after I show you this, you see the graph. We'll come back to this later so I could redraw this to show you that what we really went over. So let me delete this. Let me read this out. So now we are going to begin our problems. So first, we're going to do this equation, okay? Because we're looking for the net force, overall acting net forces on the plane here, okay? Equals to Y initial over X initial equals to 30 over 30. And then we know the difference is going to be 45 angle, right? Because they gave us that. So after we get that, we know that we have next this equation, okay? Because after we plug into the tan, that's what's going to give us the 45 angle. So now we have F to G, like this, MM squared equals to G 1.1 over 30 squared plus 30 squared, which is just going to be this over 180, not 1800, I'm sorry. So that's what we're going to get from this equation right here, right? Because we're trying to find the overall acting forces on the different angles, right? Because we have to like understand from the problem that they look like this, right? And we have to like basically find both sides to be able to find the whole thing that's going to be going across, okay? So now that we have that, we have the difference. We have the inner. Here we go. I'll just write it out here. FC equals to 2 F prime F in absolute and cosine 45. Then we have the same thing on the bottom here, which is going to be F final C be this minus F of 45. This here equal. So we work this out. We know that if we work this out from last time, we had this number that we originally just did. So it was a 6 over 1800 equals to over 2, right? From the first one I did of the 2 of this one here, right? That was what we got, right? Now we also have to do the bottom one, which was equal to 0. This one was equal to 180 squared, right? And now we have this one here. Let me write it down now. Now we have to work on this problem now. So we're almost done here, guys. We're looking at the angles. We're trying to understand like the forces, the total net force and the total Y forces working on it. So we have 2x squared equals 1, x squared equals 1/2, and x is equal to 1 over square 2. We got 6 over 180. This equal to 180 squared, which is going to be equal to 6 this. And after you do that, we're going to find out that this y, right? We're looking at the y here because we got to look at the different forces of x and y. That's how you're going to be able to find the total net force, right? Because you can't find the net force without looking at the x and y. You can't just look at x and think it's going to go only one way. You have to take account for both. So we know the y is that one, right? And after you apply it, right, we know that this is 180. So we know that after we apply the net force, let's go back to the drawing, right? get the total net force, right? Net force of X, total net force for Y, right? We're able to see that we're able to see that it's moving in this direction. When we take account the net force of Y, I'm gonna write it again, net Y and net X, right? You have to take account both of them to be able to find where the direction's going. And since it had similar numbers, it must mean that they're pretty similar, okay? So it's gonna be going in a straight parallel line like this. Thank you.